So in this video, let us see what are the traversal methods in binary search tree. So we mainly have three methods of traversing in binary search tree, which are in-order traversal, pre-order traversal, and post-order traversal. In in-order traversal, we start from the left, then we go to root, then we go to right. If we consider the example with only three nodes, which is 5, 3, 7, then in-order traversal will be left, left, root, and right, which means 3, 5, and 7. Then we have pre-order traversal where we access the root first, then left and right, that is 5, then left, which is 3, and right, which is 7. In the post order, we go for left, right first, and then root, which means we go for 3, then 7, which means left and right, and then we go to root, which is 5. So these are the three main methods of traversal in BST. So if we take the whole example into the consideration, so what will be the output? So we want left first, so we will start from 5, we will search is there any left, so 3 is left, so we will search is there any left for 3, so there is 2. So for 2 we will search if there any left for 2, so there is no left remaining here, so we will print the 2, which is the leftmost element. Then we have to print the root of leftmost element, which is 3. Then we will check if there is any right for 3, so there is right for 3. Then we will check if there is any left element for 4, so there is not. Then we will write 4 here, and we will check if there is any right element, so there is no right element for 4, so we will go to root, and then we will reach at 5 because there is no more element remaining to search in this left subtree. So as we have reached to the 5, right here 5, and then we will go to right, so right, so at 7 we will check if is there any left element, so we will go to 6, and at 6 we will check if there is any left, so there is no left for the 6, so we will write 6 here. Then we will check if there is any right for 6, so there is no right, so we will go to our root, and then we will go to the right, which is 8. Then we will check if there is any left, so there is no left, then we will print 8 here, and after printing it we will check if there is any right, so there is no right, so we will stop here, and after stopping we will get our answer as here. So this is very simple to understand, and also it is very simple to code using recursive method. So let us try to implement the code using recursive method. So I will write in order. So we will be taking root as our input, which is the root of our tree. So root, I will write our sequence here, so left, then root, then right. So our base condition will be if we find root is none, then we will return, which means there is nothing in the root, then we will stop. Then let us recursively call this function. So in order, and we want to go to the left child first, so we will write left, so root dot left, then we will print the element root dot data. As we want to print all the elements in single line, so I will write end equals to space, and I will again recursively call the function. As we want to traverse the right subtree, after traversing the left, then we will go to root, then we will go to right, so root dot right. So let us try and run this. So in order, then we will pass root of our tree, root. Let us run the code. So we get the output as 2, 3, 5, 6, 7 and 8. So let us see if it is same. So 2 3 4 5 6. Oh, I forgot to write 7 here. So we got a same output. So let us see how this code will work. So we will start with 5 as we are passing our root. Then if it is none, we will stop running the loop, because there is no chance of going forward if the root is none. But we have our root. So after checking the base condition, we will pass our root dot left in the function. So we will pass 3. So 3 will be passed, and we will check if it is none. So it is not none. So again, Inorder function will be called with 2, as we are passing root dot left. So 3's left is 2. So it is checked, and again it is check if it is none or not. So it is not. So again we will pass root dot left. So 2's left will be passed. Then we will check if it is none. So it is none. So we will stop iterating over that. After this, we have the print statement. So we are at 2 right now. So we will print the 2. So I will write over here. So we will print the 2, and then we will go to 3, because previous element which we have traversed, which was 3. So we will go to 3. After going to 3, we will print the data, which means we will print the 3. And after that we will go to right, which is 4. So we will print here 4. After that we will go to right, which is 4. So we will check if it is none or not. So it is not. So we will again check if it has the left element. So 4 left will be passed, so it is none. So it will be written the so we will print the data of the fourth node of this node. So it will be 4. Then we will go to the right element of 4. So we will pass that, and it will return us nothing. So it will go back over here. Then it will go back to 3. Then it will go back to 5. So after reaching 5, it will be at this position. So we will print 5. Then we will go to right, because after that we have right. So we will go to 7. After passing 7, then we will check if it is none or not. So it is not none. So we will check the root dot left, which is 6. So we will check if 6 has left or right. So there is no left or right for 6. So we will print 6. Then we will go back to 7. Then we are here right now. So we will print 7. Then we are checking the right. So we will go to 8. Then after passing it, we will check if it has left, and then it does not have left. Then we will print it, and we will check if it has right. So there is no right for it. So we will stop here. So this is how we will be iterating using recursive function. I hope you have understood this code. If you have any doubts regarding this, you can ask me. So thanks for watching this video, and I will see you in the next one.